Welcome to ETS 4502. Welcome back. Today I'm going to discuss analysis of experimental data with you. We are going to concentrate on research methods and errors and the source of errors. So I would be covering a sampling frame and sampling, give you some general idea as to what they are. I would later look at bias data and what are the sources of that. We would compare reliability versus validity, or reliability and validity every time we deal with data or research data. I would talk about different levels of measurements, and finally I would discuss with you types and causes of error in any data that we have. So no data analysis would be complete without first talking about research methods, because as you know, collecting data by itself doesn't really mean anything unless we put this data into some kind of a use, trying to extract some kind of an information or use it for some kind of a research or a project or what have you. So collectively, I'll call those research. So to do successful research, you don't need to know everything. You just need to know of one thing that isn't known. So you need to know, gather information about the unknown. That is true, and so on. Again, you can read this, but the one I really like is from Albert Einstein. If we know what it was we were doing, it would not be called research, would it? So again, we are, every time we gather data, we might or might not, may or may not have an idea about what we're doing. The ideal situation for us is to have some kind of an idea as to what is it that we're collecting and what would be the application. But in many cases, what we know about the data that we need to collect and its application is very small. So what exactly is research? Why is metrology so important in applied research? Well, as you know, scientific research is systematic, it's controlled, it provides us with a critical investigation. It could be an engineering phenomena. It could involve modeling, or trying to make some sense out of a data. But it is an organized and systematic way of answering the unknown. There are important components of research. Perhaps the most important component of applied research is instrumentation and sampling, data analysis, and also being able to interpret the data and make the recommendations from those data. So that's where instrumentation and metrology would come into picture, and that's what this class is all about. You are here to learn about different aspects of metrology and instrumentation, including data analysis and so on. So sampling has a lot to do with the population of interest. What is your sample population of interest? To whom do you want to generalize your results? An example of pipes, example of determining the strength of pipes. Imagine that we have, imagine if we have a huge stockpile of piles manufactured by the same company, but they come in a variety of shapes and different forms. And the first and foremost, the question that we need to pretty much answer here is, if we want to determine the strength of these pipes, obviously we won't be able to test all the pipes, because first of all, it's economically not feasible. Second of all, if we can extract the information about the strength of pipes in a good way, systematic way, by extracting, by having a few data, that would be a great disadvantage. Again, the most important thing is it's neither economically possible nor it's practical to test all of the pipelines that would be produced by a company. So are we going to measure, is our goal to measure the strength of all the pipes? Does it apply to steel pipes only, assuming that the company makes other types of pipes? What kind of pipes are we going to sample from? Is it corrugated or non-corrugated, in case a company makes both of them? Some companies, they make both the sewage and water pipelines. Again, what type of a pipe is it? Is it used for sewage pipes or water pipes and what have you? Again, this is just an example to show you different aspects of how a sample population of interest could affect the data. And obviously, as I mentioned, we cannot sample the entire population in many cases. We cannot test the entire population. So the difference, I'm going to talk to you a little bit about the bias and error now. The systematic error is called also bias. Unknown or unacknowledged error created during the design. Again, there might be many reasons for that. These errors could occur during the measurement, during the sampling. It could involve the error that's associated with the procedure or a choice of problem studies. And obviously, it's very important to realize that in many cases, errors, they tend to go in one direction. Again, this is, when we say in most cases, that doesn't mean it applies to every case, but mostly that could be the case. For example, if you want to sample, let's say, a structure, if we wanted to sample the delivery trucks that deliver the concrete to the construction site, in most cases we would realize that the concrete is much stronger than what's prescribed by the engineers. One example could be under design, there could be overflow, what have you. And it's important to realize that there are cases in which the error or bias could be at random. For example, sudden failure of a member due to extreme loading conditions could be an example. That doesn't occur in a systematic way, but it could be just a random, just occur at random for whatever reason. Again, we're not going to talk about the reason now. I'm going to get into the reasons shortly. Okay, so let me discuss a little bit the reliability and validity and the difference between the two. You probably heard the term transparency. Reliability relates to transparency. The extent to which a test is repeatable and yields consistent scores. Again, although it could be affected by random errors and biases, but when something is reliable, that means the probability of failure of the system itself is pretty low. We can never say it is 0, but it could be, for example, 10 to the -4 or 10 to the -6. So it can be as small as that. It would be interesting for you to find out what would be the reliability of a jet engine in the case of 747 and find out what that would be. That'd be a very interesting number for those of you guys that do not know about jet engines and the reliability of the jet engine. So do a little research on the internet for your own interest and find out what would be the reliability of a jet engine for a 747 Boeing. The validity of the data is to the extent to which a test measures what it's supposed to measure. Again, it's very important to realize that reliability would be affected by random errors, whereas validity would be affected by systematic error or a bias. Validity is a subjective judgment made on the basis of experience and empirical indicators. Whereas, again, reliability is repeatable and it should yield consistent scores. If not 100% consistent, the accuracy would be, the consistency would be within an acceptable range. So I have a diagram here to show you, to put things in perspective. In order to put things in perspective, just realize that if you have a target and you are shooting at a target, or again, whatever the target is, start from the left-hand side, the left-hand target. The data for this left-hand target, they are reliable, but they're not valid because they are way off the target. The second one, down here to the right, perhaps I should turn this on here. That would help more with that. Okay. The color itself, let me change the color. Okay, so this figure back here that I put a check mark right next to it, the data there is reliable but not valid. The second figure, the one right here that I just put a check mark by it, the data there is valid but they're not reliable because, again, they are, although they're closer to the target, but still they are so scattered. It seems that it is valid, but there must be some kind of an error associated with that. The third one here that I just put the check mark right next to it, the data here is neither reliable nor valid, again, because they are all in one side, they're skewed on one side. It seems there must be something wrong. Nothing could be hit under this line, and they're obviously not on the target. So that this should be a straight line. That would provide us with neither reliable nor valid. The last one that I just put a check mark right next to here, I put it actually an X right next to it, and that shows the data that's both reliable and valid because they are within the range of the target, and they are also the variation within this range is not much, and some of them they actually hit the target. So this should provide you with some kind of a schematic comparison between reliability and validity. Now, please keep that in mind. In order for data to be valid, a test must be reliable. So we can achieve valid data using reliable tests, but reliability does not guarantee validity. Please keep that in mind. There are also different levels of measurements that we can address from our tests, and that is the nominal level. The nominal level attributes to the weakest level, and it attributes to some amount of data. The ordinal attributes it can be ordered. The interval distance is more meaningful, and the ratio, which is the highest level, and it is said to be absolute zero, although that's not really true. So what are some of the causes of types of experimental errors? Well, there are three types of data that we talk about here: the single sample data, multi-sample data. Well, actually two types. The multi-sample data are obtained where we have we've performed enough experiments to verify the reliability of the results by statistics. The Single sample data are much more difficult to work with, and they may not be discovered by repetition of the experiment. So we try to have the multi-sample data as much as we can have. Because of the cost of experiments, again, we try to extract as much information with as little data. And there are mathematical tools that help us with that. Some of them are advanced topics that we're not going to address in this class, but there have been scientists working on extracting much more information from a small amount of data because of the cost and feasibility that's involved here. Here's an example of some of the different distributions that you see here. The top left-hand one is a uniform and symmetric. Again, it's the skewed to the right distribution, skewed to the left. The normal distribution is, if I can find my pen here, the normal distribution is a symmetrical distribution, this one that's marked by X, and there are also other types that are provided. Here's an example of a normal distribution, something that we would like to see for most experiments, unless they are of usual experiments. Again, the standard deviation and all that could be seen from this data. They're not really that complicated. They're pretty straightforward how to calculate standard deviation of some data, and also how to calculate the mean and all that. So if you have any questions about those, again, I'm not going to cover it in that class here. If you type the word distribution, how to calculate standard deviations and all that, and they're pretty straightforward, and you should have the knowledge from your prerequisites. But this is just a sample of a normal distribution. What kind of errors do we have in dealing with experimental data and with experiments? We can have machine electronic errors. Again, those errors are associated with the measurement device. You can have fixed errors, also known as symmetric or bias errors. These errors will cause repeated reading to be in error by roughly the same amount, but for unknown reasons. So the reasons for fixed errors are really unknown. And also random errors, again, those are caused by fluctuation. It could be human error. It could be electronic fluctuations. It could be various influence of frictions, and so on. And it is very difficult to actually establish the difference between the fixed and random errors unless we actually can detect the source of the data here. That brings me to the first part of our discussion on analysis of experimental data. As always, if you have any questions or comments, feel free to contact me via the course website. Thank you for your attention.